Hello. Welcome to this new Advanced Steel 2021 tutorial. In previous lesson, we have created two bracing UPN 180 beams by bracing tool at extended modeling of the Home tab. In structural element bracing dialog box, there are three member types. They are single, double mirrored and double flipped. If we select double mirrored as the member type, we will have two UPN 180 in the same place, they are overlap each other. But it's not what we want. In this tutorial, the bracing beam is a double UPN 180 back-to-back. If we change the gap to 180, two UPN beams will be toe-to-toe. This is also not what we want. If we change the member type to double flipped, the double UPN 180 will be back-to-back but the gap between two UPN is 0, and if we increase the gap, two UPN 180 section will be not symmetry. So that, we are going to delete these bracing beams and create them again manually. Now we are gonna add the first compound beam. Select double channel back-to-back tool on the Home tab. Hold down Shift key and right-click, then select the node option from the drop-down list. Next select the first point and then second point for the bracing beam by the same manner. Now right-click on the double UPN beam and then select Advanced Properties. On Compound Beam Properties dialog box, go to Positioning tab. In Offset field select the button corresponding to the insertion axis and then in Angle field select the radio button corresponding to rotating the double UPN beam 90 degree. Next go to Section tab and change the section to UPN 180 for both beam index 1 and 2. Now we are going to adjust the gap between two UPN. First, isolate this beam by Show Only Selected Object tool. Check the gap between two UPN 180 by D command. The gap is now 61.6. The designed gap is 12 mm, so that we need to move two UPN toward each other 24.8 mm. Now right-click on the double UNP beam and select Advanced Properties from the context menu. The current value of offset on X is 50, so that we need to decrease it down 24.8. Now we are going to change the offset on X of the beam index 1 to -25.2, and 25.2 for the beam index 2. And check the gap again by D command. Now show all other beams and columns by All Visible tool. We are going to add the second compound beam by the double channel back-to-back tool on the Home tab, and use MA tool to copy the properties from the first to the second. Now right-click on the second compound beam and select Advanced Properties from the context menu. We are going to rotate it 90 degree around the compound beam axis. Because the first compound beam go through the other one. So now we are going to split the second compound beam into two parts. Select the Split Beam tool on the object area in Home tab, then select the second beam. Next we select the intersection point of two double UPN for split point. Now as you can see the second double UPN beam is discontinuous at the intersection point. Now we are going to add a joint connection between two compound beam. It is detail 5. We are going to try Gusset plate in center tool for this connection. Select the first diagonal beam, and the second and then select the last one. Oh, nothing happened. We have another solution for this situation. We are going to create it manually. We are gonna to add the plate 12 mm first. Now create two diagonal lines inline with two WPN beam axis. Start the line command by typing L and hit enter. Hold down Shift key and right-click. A context menu for snap override will display, and then select Node option. Now select the upper point, and then the lower point. We create the second crossing line by the same procedure. Now we hide two bracing UPN beams by hide command. Now we are going to offset the first line 265 mm to the both sides. And offset the other one 200 mm to both side too. We will trim 4 corner by using fillet command while hold down the Shift key. And we are going to joint 4 line by joint command. Now we are going to create a plate by Plate at Polyline tool. On Plate dialog box, click on Shape and Material tab and type 12 in the thickness field. Switch to Positioning tab and select Middle for justification. Now we are going to add some bolts. Connect plate to UPN beam by Bolt on Plate tool. Select Bolt Anchors Holes on Plate tool on Advanced Steel Tool palette. Then select the plate first, and then select the UPN beam. Now as you can see 4 bolts have been added. Now switch to 2D to get the distance between two bolt rows and the distance between two bolt columns. And the distance between outside bolt and the plate edge. Now right-click on the bolt box, and select Advanced Joint Properties from the context menu. There are two options for layout. They are center and edge. In this tutorial, we are going to select Center option in the Layout field. Then type 50 for Enter. Dist along X, and type 80 for Enter. Dist along Y2. Now check the distance between two bolts along X and also check the distance between two bolts along Y2. Then go back to bolts, anchors, holes on plate dialog box. Now we will move bolts outward the plate edge, along the X-axis. But first we need to check the distance between center bolt to the plate edge. It is 107 mm. If we want this distance as 35, we must move the bolts outward and along x-axis 107 minus 35 equals 72. Now go back to bolts, anchors, holes on plate dialog box, put 72 in offset field along X. Now check the distance between outer bolt and the plate edge again. Next we are going to insert bolts connect the gusset plate to the lower discontinuous UPN. Type 50 for X and 80 for Y. Intern. Dist field. And then go to the Joint Properties dialog box to adjust the bolt's position along X-axis. Finally we insert the bolts connect the gusset plate and the through UPN. There are 6 bolts lying in 3 rows and 2 columns. Type 2 in X field is number of columns, and Type 3 in Y field is number of bolt rows 2. An input 105 is inter. Dist value along y-axis, and input 80 is inter. Dist value along x-axis. Now we are going to chamfer 4 corners of the rectangular plate. We are gonna to use the corner cut tool. Select corner cut tool on the advanced steel tool palette and click near to the corner where fillet will be created. Type 100 is the first chamfer distance in X field, and type 265 is the second in the Y field. Do the same procedure for the rest. Now we need to cut back the end of the discontinuous UPN beam. The designed gap between the end of discontinuous UPN and flange of the through UPN is 50 mm. So we need to cut the discontinuous end 140 mm. Now we are gonna to move UCS to the discontinuous UPN beam. Select the UCS at Object on Advanced Steel Tool Palettes. Then select the discontinuous compound UNP beam. And then select the UCS symbol. Now move the current UCS to the node of the discontinuous beam. Now we are going to use the shorten tool to cut back this 2 bracing beams. On shortened beam dialog box, type 140 in reference as cutback value. And do the same procedure for the lower discontinue UPN. Now we have just manually create a joint connection between two bracing UPN beams. Thank you for watching and see you soon.